So leaves learn a MAC and or IP, they tell the spines. So these spines should know about all these endpoints and which leaf or leaves they are behind. Now, over the next few slides, we're going to look into the Kube database on the spines. But before we do that, we need to get the VNID of the bridge domain and the VNID of the VRF. So notice I'm running this from leaf 1. I'm running this long command, and I want to get the VNID. That's the special VXLAN VNID we used. I talked about that earlier when we send traffic over the ACI fabric. So we want to get these two IDs for this endpoint if we want to look at the information for this endpoint in the Kube database. So remember these numbers. The BD VNID ends in 915. The VRF VNID ends in 760. So notice here I'm attached to the spines. So the Kube database runs only on the spines. And I'm running this really long command. I'm not going to cover every word of it for you. But remember, this is the bridge domain VNID. And then this is the MAC address of the endpoint we're looking for. And then we're egrepping, because if we don't put all this egrep in, the Kube database is large. We'll get a lot of output. So there's a few things in here. So we can see the MAC address. We can see its bridge domain VNID. We can see its VRF VNID. And I want you to look at the output here. I have a question. What is which leaf switch? Can you tell which leaf switch has advertised this endpoint? So remember, one leaf switch is going to own one endpoint connected to leaf 1. Oh, I just gave it away. So leaf 1, I don't know if it's leaf 1. But anyways, the way I can tell which leaf switch it is this IP. So remember, this is the TEP IP. We talked about the TEP IP addresses earlier. Each leaf and spine get a TEP IP. So what this tells me is this endpoint is behind a leaf switch with this TEP IP right here. Ends in .92. I'll show you how to find which leaf switch this is here shortly. So we're running this command to see the MAC address entry in the Kube database. We can run a similar command to view the IP entry in the Kube database. So this time I'm specifying that VRF VNID. And here's the data. So we have the endpoint's MAC address, the endpoint's IP address. We have the VRF ID. So we have the VRF in which that, in the endpoint resides in. And then this is the publisher ID. So that's the leaf switch that advertised it to the spine. So I want you to remember that TEP IP, 11.0.292. So to figure out which leaf switch advertised that IP and the MAC address from these previous two commands, you run this command. So again, I want you to look at the output. Feel free to pause the video. And I want you to tell me which leaf switch advertised that endpoint. So the answer is leaf 1. So remember that IP.92 right there is what inserted this entry into the Kube database. The last thing we're going to talk about is a bounce entry. So think about this scenario. So let's say we got a few things to digest here. So we have a local endpoint to leaf 2. Let's say it's a virtual machine. It's got an IP and a MAC, and leaf 2 knows about its IP and MAC, and it updated the spines. So the spines know that that green endpoint is behind leaf 2. And let's say there's another server here behind leaf 1. And it's, sending traffic over to this endpoint. So leaf 1 thinks that this virtual machine is behind leaf 2, which it currently is. But what happens if that endpoint, that green endpoint, moves? If we vMotion it to a different host, and that host is behind leaf 3. ACI needs to handle this. It needs to handle this vMotion. The IP address and the MAC address are no longer behind leaf 2. They're behind leaf 3. So what happens is leaf 3 will have a new endpoint learn. So let's say it learns this endpoint's MAC and IP. What it will do is it's actually going to send a COOP message to the spines. So the spines are going to say, oh, this IP and MAC are no longer behind leaf 2. They're now behind leaf 3. And so what the spines will then do is they update leaf 2, saying, hey man, leaf 2, that endpoint is no longer local to you. So update your table. This MAC and IP, update your endpoint table. They're over behind leaf 3. So what we're going to create, another thing we're going to do. Now remember, we updated leaf 2 here. The spines did not update leaf 1. So leaf 1 still thinks this green server that's behind leaf 3 is really right here behind leaf 2, if you look at its endpoint table. So if this server was to send traffic, it's going to send it to leaf 2. So to manage that, what they create in ACI on leaf 2 is something called a bounce entry. So leaf 2, notice for this IP and this MAC, it's behind leaf 3 over that VXLAN tunnel, and this is a bounce entry. So what's going to happen is the server on leaf 1 is going to send traffic to leaf 2 because it thinks this endpoint's still right here. Leaf 2 will look at its bounce entry and say, oh, that device is not local to me. I'm going to punt it over the VXLAN tunnel to leaf 3. Now, when this endpoint's going to respond back to this server over here behind leaf 1. So it's going to respond back, and the message will come back on leaf 1. Leaf 1 right here is going to update its endpoint table because it's saying, hey, this traffic's coming from the TEP IP of leaf 3. So eventually, leaf 1's endpoint table will get correctly updated. Now, why do we do it this way? What's the benefit? So why didn't we update leaf 1? Remember when we went through this previous walkthrough, when the spines got up, found out that there was a move, they only updated leaf 2. They didn't update leaf 1. So I did some digging into this. The reason why they designed it this way is they wanted the whole endpoint move process to be very simple. They only wanted to update 3 devices. So we're going to update the new device, the virtual machines behind. We're going to update the spines. You can consider that like the second devices. And then we're going to update the original leaf that virtual machine was behind. So just 3 different things that need to get updated. New leaf, spines, old leaf. They didn't want to have to worry about going out and pushing an update to all leaves. So what they do is they create that bounce entry on leaf 2. So leaf 1 would send it over to leaf 2. But again, leaf 1 will get updated eventually via data plane about that remote entry. That's pretty much all we have. So in the next part of this lecture, I'm going to dig in deep to all these different VXLAN IDs and VLAN IDs so you can understand how they work in ACI. All right. Thanks all.